r value is going to be the square root of our a or our x. I should make my square root a little bit longer. So that's going to be, well, let's just real quick rewrite this as the point -3. 3. Sometimes it helps people. Other people don't need to do it. Either way, whatever makes it easier on you. So it's going to be -3 squared plus 3 squared. And that's going to equal 9 plus 9 is going to be square root of 18. 9 goes into 18 twice, so it's actually going to be 3 square root of 2 for my r. Let's go ahead and find our theta. Whenever I'm looking at theta, I might as well draw the picture to make sure I'm subtracting or adding correctly. A -3, 3 would be somewhere over here. And our alpha is going to equal tan inverse of our y value over our x value, so that's 3 over -3. So that is the tan inverse of -1 actually, which is going to be a -45 degrees. If you didn't draw the picture and you come out with a -45, that tells you it's either 180 minus 45 or 360 minus 45. Which one is this one?
180.
It is 180. So we're going to have theta equals 180 minus 45 degrees. That's going to be 135. And so our finished answer is r. Our r is 3 square root of 2. Times the quantity cosine of whatever our theta was. Our theta was 135. Plus I times sine of 135. And we are done. Questions on any one of those steps? If that is completely confusing to you, you really need to study for Friday, because we've done this formula and this formula about 1 billion times so far, right? In one shape or another. It's just being able to apply it to the certain situation. And that's where the practice comes in. All right. So no questions on the bell work? No. Thanks, Luke. Test on Friday. We will start reviewing tomorrow. The review I will give you will be pretty comprehensive in the fact that if you do all of it, I will pretty much pool, that'll be the pool of type of questions that will be on the test. So if you can do everything on the review tomorrow and Thursday, this test will be easy. I'm hoping this test is going to be pretty easy for most of you. I'm hoping to have like a median or an average of around like a 96%. Just because it's only 2 sections, it's just on vectors and complex numbers, and it's almost the exact same stuff.
Will
Yeah.
we get half corrections just in case?
So what I'm leaning towards, just because the next week is prep week for finals, I'd rather you front load and really study this week. So I'm thinking of, and I'll tell you for sure tomorrow, I'm thinking of the only way you can do corrections is if you get less than an 80%. And then the max you can get is 80%, because I really want you to focus on doing really well on this test, because we've spent a lot of time on it, and I'm giving you such a small section of it. Last year they had all of Chapter 7 all as one test. And you guys just have 7.3, 7.4. Yeah. So it's not a ton of information, so you should, if you practice, you shouldn't have to do corrections, honestly. If you really think you messed up something, come talk to me individually. But otherwise, you should all be happy with your score from Friday. All right, questions from the homework. Lizzie.
Number 13. I'm just confused on how to like.
Oh, I don't have it on there. For number 13, how to plot points? Oh, okay. So 13 is a plotter pointer. Let's just do it on here. We'll do it on here. I don't actually have the points in front of me. Could you give me the point?
It's 2, negative pi over
2, negative pi over 4.
You just only have to plot 1 point. You don't have to do the 2.
Right. You only have to plot 1. That's why I only have 1 point on each one. So 2 negative pi. So the only reason why I have 2 points is so you can see what I'm thinking in my head. So this is just all in my head. I would go out 2, right? I wouldn't write that down. I would just kind of move my pencil out 2 units. And then negative pi over 4, well, pi over 4 would be 45 degrees, so negative pi over 4 would be negative 45 degrees, or it'd be like right about here, Lizzie. Right about there. And I wouldn't have any of this down, right? Because it's putting too much on your graph all at once. So if I did write it down, I'd probably erase it really quick so I didn't have to worry about it later on.
Thank you.
Does that make more sense? Okay. Remember, this stuff will not be on the test. If it is, it would be extra credit. It can definitely be on the final, the stuff we're learning yesterday and today. It will hopefully be an easy question on the final, though. All right, any other questions from the homework? There was a mistake on the homework.
There was.
It wasn't, I mean, it was a mistake. It was a big mistake. The actual answer wasn't incorrect. It was number 49. I had y equals -2 cosine 1.1 when it should have been sine, but the answer I came up with was correct. So it was the fact that I knew the answer and I just worked backwards from there. In case you were wondering about why both of those are cosine. Y always has sine, x always deals with cosine. All right, today let's talk about graphing polar equations, and the bulk of the lesson today is going to be using your calculator. All right? But first, before we use our calculator, let's learn how to plot and practice that stuff. When we're plotting, so when we plotted something like x squared, and the rectangular coordinates where we had normal x, y values, if I asked you to plot x squared and you had no idea what x squared looked like, you would just plot a bunch of points. You would take like x equals -2, -1, 0, plug it in, and come with those points. That's exactly what we're going to do here for our escape the program. For our polar equations, we're just going to pick a bunch of points and see what kind of shape they make. They also have parent functions. Just like in rectangular form, polar functions have parent functions that you can make smaller changements and moves left, right, up, down, bigger, smaller. So we're going to start off with one of the most basic shapes, and that is 5 times cosine theta. What we're going to do is we're going to build up to our ordered pair. So I picked a whole bunch of degrees for us, just basically 0 through 180. You could have picked as many as you wanted in there. We're starting at 0 degrees. The first thing I'm going to find is the cosine of 0 degrees. Most of these we're going to have to put on our calculator. So we're going to do the first two together, and we're also going to do 120 together. So the cosine of 0 degrees is the big 1, which means 5 times the cosine of theta is going to equal 5. And our ordered pair is always going to come in the form r comma theta. So our ordered pair is going to be 5 comma 0 degrees. Now we're going to go ahead and plot that on our coordinates on the right. So that tells me to count out 5 units. I will erase this, but basically in my head I'm going 1, 2, 3, 4, 5. Maybe I'll put arrows so you can see that stuff a little better. 1, 2, 3, 4, 5. I'm counting out 5 units, and I'm moving 0 degrees. So that means I'm neither going up or down. I'm just putting a big old dot right there. Let's go ahead and put it in red. Like I said, I'm not going to keep all those arrows. That's just so you can see what I was thinking in my head. That's where I got 5, comma 0. Let's go ahead and do the next one. So the next one is 30 degrees. So cosine of 30 degrees is on our unit circle, but I want the decimal version so I can actually approximate it on the graph. So I plugged it in and I came up with cosine theta is going to equal about 0.87. Multiply that by 5 and we'll get 4.4 out, which gives me the ordered pair 4.4 comma 0. So that's kind of the pattern I want. I want to round my cosine theta to the hundredths place, and I want to round my 5 cosine theta to the tenths place because I can't plot any more accurate than that. Yes? Would it be 4 point? Oh, 30 degrees. Yeah, sorry.
Nice.
Noise. Yes, 30 degrees. And to plot this, once again, in my head, I'm counting out 4 units. 1, 2, 3, 4 units, and it's about 4.5. So maybe I'm thinking here. And I'm just rotating it till I get to 30 degrees. So in my head, I'm going up there. I'd put my plot here. and all that stuff was really in my head, or I'd erase it. And so I just end up with the point there. All right, we're doing one more together, and that is at 120, because 120 takes a sharp turn. At 120 degrees, we are going to get out negative 0.5, and multiply that by 5, and we're going to get negative 2.5, which will give us the point negative 2.5, comma 120 degrees. Here's where we come into a little bit of problem. And whenever we have negatives in there, because it's way different than how we'd graph, x, y coordinates. So we're going to count backwards 2.5. So we start at our pole or our origin and go backwards about 2.5. So I'm talking about right here. Now I need to rotate it 120 degrees. The problem is my numbers no longer match up. They no longer match up. So what we're going to do instead is we're going to locate 120 degrees on our unit circle, which is right here. I'm going to, in my head, keep that in mind where 120 degrees is. Now I'm going to rotate my point until I hit that line and make my point right there. And if we do the math really quick, this is 300 degrees. 300 degrees minus 180 is 120. So in fact, this is 120 degrees. So that distance I just did is 120 degrees. Yes?
I got that same point, but I just went to, so I went to negative 2.50 on the thing, and then I just added 120. Does that work too?
You added 120.
So like I was at negative 2.5 with 180 degrees.
And you added, yeah, that's what I just said. Because 300 minus 180 is 120. Sometimes it's easier just to read it and know where your line is. Sometimes it's easier just to go, well, I know what 120 degrees is. I know 120 plus 180 is 300. However you do it, just make sure you're doing the 120 degrees from here and you're not just putting it up here because you see the 120 up there. All right, you are now in charge of all of the rest of those points. I'll give you a little bit of time and then I'll just show you the picture of what I got. All right, here's what I got for my drawing. If you take your time and plot it correctly, it makes a really nice circle. And more importantly, it makes a circle with a diameter of 5. That 5 comes from that 5. This would have been 10 cosine theta. It would have looked exactly the same, except this point would be over 10, so it would just be a bigger circle that still starts in the origin and goes right. So anything that's cosine theta, that's just cosine theta, is going to be a circle. As long as you're just multiplying on the outside. Sine is also a circle. If you would plot all of those points, it's only 4 of them, so it doesn't make a nice circle, but you can make it a nice circle. It would look something like that. It would also be a circle. The diameter of this is 4, except this time instead of going right, sine goes up. So these are 2 parent functions on the polar coordinate system. So they're always going to look the same. You can always come up with them just by knowing that first number and whether it's sine theta or cosine theta. Okay, what we're going to do next is we are going to use our calculators to plot the rest of them for us. I want us to pay attention right now. Do you see this spot that says note to yourself? At the very least, you need to put radian mode. Your calculator must be in radian mode for your answers to match mine on most of these.
Why does it say polar mode?
Because it's 2 modes we are going to switch. Polar is as opposed to rectangular, and radian is opposed to degree. So in the polar axis, you can have, if we look here, you can have degrees, and you can have radian measures. However, if we have different, if you're using degrees and I'm using meridians, our pictures are going to look different.
Okay, so we have to use radians.
Make sure you use radians so your answers will match mine. And we'll stick with radians if we're talking about polar. Okay, the first thing we're going to do is we're going to make sure our calculator is in the proper mode. So we're going to bring up our calculator. Let's see if I don't have mine up anymore. Let me get mine up.
That's a squirrel. Can we use polar mode if we have it?
Do you have a graphing calculator? Yeah. That's exactly what we're going to do. We're going to go to our mode button. We are going to go to our mode button. Shh, guys, stick with me, otherwise it takes forever. Because people are going to be 8 steps behind, and then all of a sudden they'll be like, what's the mode button? Mode button is right here. Make sure you move down to radian, and radian is selected. And you move down here where we have function, parametric, polar, and we're going to go to polar and make sure that one's highlighted. So you go to where it's flashing and you hit enter and make sure it is highlighted. You will know you're in polar mode because if you hit this y equals button on the top left-hand corner, it's going to say r equals instead of y equals. Also, if you hit your X button, what normally would be your X button, you'll see it now comes up as theta. Your normal X button. It's right here. You're just going to hit that button and it'll come up as theta if you're in polar mode. Still pointing to it. Still pointing to it. Still pointing to it. This is your X theta button.
I can't see it.
Just hit this button.
I'm in Deutsch mode there.
This button here. See how complicated it is if people are just on their own, just hitting buttons and not paying attention? It just took us 2 minutes to find one button on our calculator I've been pointing to this entire time. All right. So what we're going to do is we're going to put that equation in. I forgot what equation I gave you. We're going to plug in 3 times sine 2 theta. Now do it carefully because the 2 theta needs to be in the parentheses. So make sure yours looks like mine. I'll have 3 times sine of 2 theta and then close parenthesis. Oh, come on. No way. No way. He asked for the theta button.
I have a different calculator.
Oh, that's true. Yeah, he has the Casio. He has got the Casio.
I was trying to figure out.
Nope, I got you. His is going to be completely different. He's going to be lost for a while. All right. Then we're going to go and hit graph.
Right, top right. Oh my, it's an X.
All of our graphs might look different, but what's going to make ours all look the same is just find that zoom button here. There's a zoom button, and then you're going to scroll down until you hit standard, or you can just hit 6 and hit enter. Now all of ours are going to look the exact same. That's because yours might have already been zoom standard. Is yours broken?
So it's
Zoom standard? Yeah.
what do you do?
I don't know what mode yours is in. I don't know what you did. You didn't even type anything in here.
Oh, I got rid of that because it just like did a line.
Oh. What was the form? What was it?
3
Sine 2.
sine. Oh, there we go.
So you have to figure out how to change this into a regular XY coordinate plane. You probably have a stat plot on or something. Let's look here.
That's what comes up.
You know, it comes up and then it
See the stat plot that's on? It says on there.
Nice.
We would just go into it and click off.
And then you go to.
And then it should, there you go.
We are, right?
Yeah.
I did, I put it in
Yeah,
3 times.
yeah.
Will's trying to fix it, but it doesn't work.
What does it say?
Wanna see what
It says
happens?
error dimension.
When you press
Yes.
graph?
So yeah, so,
Invalid dimension.
yeah, thanks, Will.
I can hack it in.
So what's probably happening is probably one of your plots are on. See it second stat plot, do you see that stat plot's on?
Yeah.
You would go into it, make sure it's off, and then it'll probably, because stat plots don't work as well in Polar, it mixes. Alright, does everyone have this graph in front of them?
Yep.
Do you see how it's kind of far away? It'd be hard to kind of gauge where everything is.
Yeah.
Yeah.
Zoom. Go to your zoom button.
Zoom in.
And you're going to go to zoom in. Now hang on, stick with me. Stick with me. Hit enter. Now just wait. Just wait for a second.
Mine didn't change.
It shouldn't change. That's why I said stick with me. Move your cursor keys up and down and left and right. You're going to see an X start moving. Where that X is where it's going to zoom into. So if I hit enter right now, it's going to zoom in on that clover.
Mine's like a cross.
I kind of want to put it right in the middle, so put that crosshair right in the middle of that butterfly,
So 0, 0.
and then hit enter. And it'll zoom in right there. But it will zoom in, kind of like if you pinch at a certain part of a picture, it'll zoom into that part.
Can I zoom in again?
You can zoom in again, but it's not going to help you. But you have to hit zoom in twice. So do not keep going zoom in and saying it's not working. You have to move the crosshair you want to and then hit enter, and then it will zoom in. And in fact, in most of your calculators, they'll just keep zooming in as you hit enter. Oh yeah. And if you ever want to go back, you can either hit zoom out, or you can go back to zoom standard.
Wait.
All right, now we have to plot this on our sheet. So let's try to collect ourselves to plot this on the sheet. You can play with this as much as you want in a minute. Pay attention right now. I don't want to keep going over this a billion times how to graph this. Notice this is an XY graph. I'm trying to transfer this onto a graph that has circles on it. So what I'm going to do is I'm going to pick a key point on this 4-leaf clover. Let's pick this point here. I'm going to approximate where that is on this graph and put it on my regular polar graph. So I'm going to count this out. 1, 2. This is a little past 2. And it's a little bit higher than 2 here. So what I'm doing in my mind, I'm actually going to put it on here. I'm going to count out about 2 spaces a little bit further on here, and in my head I'm picturing straight up. That's not really straight up. But I'm picturing straight up. And then on the y-axis I'm going to count 2 up and a little bit more, and I'm thinking in my mind, go across. So this will be right here, that point on that 4-leaf clover. I mean, it's a little big.
How do you know to go up to 45?
I didn't. I mean, we know it's 45, but like I said, on my graph, all I'm saying is on the x-coordinate I go over 2 a little bit more. And this one says go up a little bit past 2 more, and I'll get to that point there. So to put that on here, I forget about the circles for a second, and I just think a little past 2 straight up. And I go on my y-axis a little past 2 and go straight over, and it makes that point there, and then I connect it like a 4-leaf clover. And I just do that. And then you can get your other points. I'm not going to spend time doing that, but we can get that point over there. It's going to be about there. Get that point over here. And get that point over here. I'm not expecting perfect points. I'm just looking for key points that you looked at your graph and you could transfer it onto this graph and how it looks there. Nice. Okay, now I want us to graph the next one. Yes. Yeah. Okay, so I'm going to plot the next one with you. So we are going to do R equals theta. And if you're not zoomed properly, you're going to see that, and it's going to tell you you're not zoomed properly, so I'm going to go back to zoom standard. I'm going to go back to zoom standard, and I'm going to get a look that looks like that. Now, here's the limitation of your calculator, how your calculator is set up right now. It is only showing you 360 degrees of rotation, but that spiral will go on forever and ever and ever. So let's plot this first, then I'll show you how you can change the settings in your calculator to make it keep graphing further and further and further. So once again, you're going to look for key points. You're going to say to yourself, this starts at the origin and crosses about 1.5, crosses here. What we can do to zoom a little bit into this, so hit zoom in real quick and tell yourself that that's too far zoomed in. You can't see all your key points. Just hit zoom in and hit enter. Am I right or wrong? Are you zoomed in a little too far?
I'm way too far zoomed in. I can't see it.
Way too far. So what I want you to do instead, go to your window key. Shh. Go to your window key. This says that my x min is at -10. Yours is going to be different because you zoomed in. I want my minimum to maybe be -7. Let's make that -7. That'll be my lowest x value that my graph shows, and let's make it go to 7. And we're going to do the same thing for the y min. We're going to change that to -7. And we'll say we'll go our max of 7. So I just zoomed in a little bit. I just zoomed in from -7 to 7 instead of -10 to 10. Now let's go ahead and hit graph and see if that zoomed in where I wanted to. Is that a little better?
Yeah.
I can still see all the points, but they're a little closer.
Wait, how? What's the exact same? What's the same?
So I have these weird little dots. You know what those are?
Those are from a stat plot somewhere. You have a stat plot turned on.
You just press enter.
Yep, and then off.
Oh, okay, thank you.
Try that. All right, now I want you to plot that on your sheet using key points. Considering we start at the origin, we cross at what looks close to 1.5. Then it crosses a little past 3. Then it crosses a little past 1, 2, 3, 4, almost at 5. Bless you. So use those points. So we're about here. I can't see mine all the way. So then we're a little bit above 1. Shh. A little past 3. 1, 2, 3. And almost at 5. 1, 2, 3, 4, 5. And you're just going to put an arrow on it saying that it keeps rotating forever.
Oh, whoa, that.
And I'm going to show you for a fact that this rotates forever. So you should have the graph in front of you. You should be able to graph it on your own. Should just look semi-similar to that. This should probably be a little further out. I graphed the major points. Do we all pretty much have that graph done? Okay, I'm going to go back to my calculator and I'm going to show you something. This only happens with polar, but in polar coordinates we have this, what's my theta minimum and what's my theta maximum? Maximum is currently at 6.2. If I would change that, let's say I'm going to change that to 15. And then I hit graph.
Should we be doing this?
If you want to, you're going to see that your spiral goes further and further. Now if I hit zoom standard, oh, I got to go back to my window. I got to change that back to,
What the heck?
let's make this 15 graph. You're going to see that it starts showing that the spiral goes further and further. And the bigger that number is, the more rotations your calculator is going to do. So you could zoom out even further and do more, and you could keep it going, spinning and spinning. You don't need to erase it.
No, I did it. Mine like.
Oh, you had the wrong graph?
Like that. Yeah,
Oh, okay.
it's like, well, now it's.
Oh, okay.
It has to be completely different. Yeah.
All right, so what I'm expecting out of your homework is kind of play around with your calculator. The homework should not take a long time because I'm just expecting you to use your calculator to come up with these graphs, and you're just going to make them approximate. I do want to make one change really quick. Number 61 should be 1 plus cosine theta. 61 should be 1 plus cosine theta. 61 should be